Hello everybody! As you have seen from the introduction sequence, we have added a lot of new elements to our game. We have added new collision element, we have added an ambient sound, we have added a level select screen, and most importantly we have also added support for iPhone 6 and iPhone 6 Plus. So in the next few minutes we will talk about how I've created all of these, and we will get into details on each of these elements. Here the level select screen, which if you look in LevelHelper, it doesn't look like how it looks in the when the game is run. Over here we have some numbers which are not present in the level helper screen. So what do we have here? If you look in the C navigator, you will see some objects that are locked. These are actually assets, and what assets do is basically you create a representation of a complex object, and then you multiply it as many times as you like. You put it in how many levels you like, and then if you need to change it, make a modification to it, well, that change will be visible everywhere you use that asset. So for example, over here I use the asset 10 times, and if I am to unlock and modify one of it, it doesn't matter which one I modify. So for example, I will just drag the stars over here to the top, and then I'm gonna lock it and save. It asks me if I want to do that. As you can see, everything everywhere this asset has been used has been modified to reflect that change. So that's the power of assets, because I wanted to be able to change these buttons that I have created right here instantly without changing, doing this every change, doing it 10 times. So let me put the stars back over here. Then I'm gonna lock, and now I'm gonna explain to you how this was created. So to create an asset, what you do is go in the C navigator, go to the plus button over here, you just choose asset, and then you'll have a node object, an object that looks like a node and behaves like a node, only that whatever you put inside of it as a child, it gets saved, and that representation is saved on the disk. Then you can use that asset everywhere in all the levels you want, and many times in the level, and whatever change you do inside that asset will be instantly change everywhere that asset is used. So let's create basic asset for the moment. I'm just gonna drag this leaf over and maybe a star, and then I'm gonna go back here. I'm gonna put this leaf and this star inside my asset. Let's rename this to demo asset, and now I'm gonna drag this leaf so that it's sort of like in the center of my asset, but it's not really required. But it's better to have things organized visually so that you can work with your level much simpler in that way. I'm gonna put this leaf over here, and let's change the Z order to be on top. And now I'm gonna click on this lock icon. I'm gonna choose save and lock the asset. And the first time I'm doing this, just the first time, and it will ask me, okay, do you really want to change the the changes and everything like that? And I'm going to choose save. And the very first time it will ask me, okay, where do you want to save the representation on disk for this asset? And I have this folder over here created in my project called assets, where I have the level select buttons also. And I'm going to choose demo asset as the name, and I'm going to choose save asset. Now if I go in the project navigator over here, I'm going to go into the folder assets, and I instantly see this asset over here. Now I can drag it as many times as I like. I can even Command C and Command V to copy paste it. It doesn't matter how I duplicate this. And as you can see, I have the demo assets here 4 times or something like that. And now if I change one of it, it doesn't matter which one. So for example, let's put the star over here at the bottom, and now I can choose to revert my changes, so revert to the one saved on disk, let's do that for the moment. And in that case, it will ask me, are you sure you want to revert? And I will say yes. And basically it reloads that asset to with the representation that it's on disk. And now let's actually save it. And I'm gonna do this little change over here. I'm gonna choose save and lock the asset, save and lock. And as you can see, everywhere it was used, it has instantly modified to reflect that change. So that's how simple it is to use assets. Now, it is very important that you understand that assets encapsulate your object representation only for what's inside of it. So you have to look at what's inside. It will get saved, and it will change that representation everywhere it's used. But whatever it's outside, so whatever you put on the asset node itself, it's per that node. It's not for every assets out there. So for example, if I put a user property like I have over here for each of my button, they have the button information user property, and in a moment I will show you how to create that property. Well, that user information is per node, per this button asset, you know. So it's not it's if you change it over here on this object, it will not reflect on the other one, you know. So the changes that reflect through through the assets used are only what's inside of it. What's outside, what is on the asset node itself, it's for that node only. So you can have this asset, for example, you can have it scaled. So I'm gonna scale it to 2 over here and to 2 over here. Okay, in my case, this asset is actually right now it's unlocked. So I'm gonna save this. Okay, so as you can see, this is bigger, but this is smaller because these still have the scale 1 over here, but these have scale 2. And that way you can have it so that an asset is rotated in one place and it's rotated another way in another place, but they both represent the same object. So you can have animations on the assets that play different. So if, for example, inside the asset you have a character, then you can multiply that character as many times as you like, but in your game it can run different animations. So one character can run, one character can walk, one can jump, but they both represent the same character. For example, when you have a game with multiple zombies in it, each zombie may do something different, but they basically the same representation. They look the same, you know. So that's about asset. And now let's go back to our screen over here. So let's remove these demo assets. We no longer need it. And if we look over here to the assets object over here, you will see two things that are very important. We have added user property over here, which is called button info. And over these properties will be the level file that we must load when we click on this button over here, and the ID. So the ID is 4 over here. We will use the ID to actually change the texture over here. So based on the ID, we will have the number 1 over here, number 2 over here, number 3 over here, and so on. And that's how we have different visual representation over here than what we have in LevelHelper, because we use the ID to change the sprite representation for the number. And another important thing we have over here, it's that we are subclassing this asset node in order to add our own implementation in code. And I said that the class that needs to be loaded by when we load the level it's level button asset. So in a moment we will look at the code and see what we have there and how we have subclassed. Now when you subclass, it is very important that your class, so in my case level button asset, is actually subclassed from LevelHelper asset node. So if I have a node, for example, like this, and I want to subclass this object over here, I have to subclass it from LevelHelper node. So this part over here tells me what's the superclass of the implementation I will create in code. So let's remove this and let's focus on the user property for a moment. Now, if you go over here to Tools, Property Manager, or you can also select your object and go to this button over here, which will open the same area. You will see that we have some classes over here that have been defined. It's the level info, which only have the level ID member variable, and the button info, which have the level file that we need to load, which is a string property, and the level ID, which is a number property. We can add more properties over here, or we can add different classes. So for example, let's add a demo class, and we can add my member variable, and we can have it to be a boolean, a connection, a number, or whatever we like, and we can instantly see the code that will get generated over here. And if we go over here and, for example, let's create a demo node over here just to assign that demo property. I'm going to go over here, I'm going to choose demo class, and now I instantly see my variable, which is a boolean. So I can change that. Let's add another member, string member, and connection member. Let's make it connection, and a number member, and let's make it number. Now if I go into the level editor over here, I can see these properties over here, and you will ask, this is a boolean, this is a string, and this is a number. We can change that value, and this is a connection. You will ask, what is a connection member? Well, basically this is a pointer to another object, so we can have it so that when we are maybe subclassing or doing something with the object, we have to look at the state of another object or something like that, and we can connect this to another object over here. So I can choose to connect it to the leaf object or something like that, or to the background, and we can look at the state of that object or something like that, and you can remove the connection and stuff like that. So let's now that you know how to create properties, if you look over here, it will tell you that these properties will be generated inside LevelHelper user properties.h. So if you look in the code over here, we can go to the API, and you can go to the protocols and user properties.h, and you can see the generated code over here that you can use. Now let's focus on the fact that all these asset nodes are subclassed from the level button asset. So if you go over here, you will see that we have a class level button asset that we have created, which is subclass from LevelHelper asset class. So that's why we have subclass of LevelHelper asset over here. It's important that it's the same. Okay, so what we must do in order to subclass any node from LevelHelper, so anything that you created from the plus button over here in the scene navigator, so we have shapes, gravity area, water area, camera, rope joint, parallaxes, Bezier nodes, sprites, and everything like that can be subclassed so that you can add your own, you can extend with your own implementation. It is important that when you subclass, you actually add these two methods over here. Node with dictionary parent, init with dictionary parent. It's like this in all the engine. And now if you go into the level button asset over here, we can see that we have added a lot of methods over here to help us with our game. So in a moment, I will get to what we have added over here just in a moment. But now the very important thing when you subclass, it's if we go to level select scene over here, you will see that we have this method over here, this create node object for subclass with name supertype name. Now this is because the LevelHelper API doesn't know about your classes, and it will tell you, okay, I need to create an object that you said in LevelHelper that it's a subclass of level button asset. But I don't know what that class is, so please give me the class so I can create that object with the class you want. So that's why over here you just need to return ns class from string and using the subclass type name over here, and over here at the top make sure you import that header file so that the ns class from string can actually return the exact class you are looking for. Now in the case where for example the class property over here, it's not named exactly like the class you have created. Now you can do an if check if ns string it's equal with something that you've written over here, then you can return your own class. That's very, it allows you to have a greater control. Now let's look at the level button asset class that we have created for our asset buttons over here, and let's see how we have done so that each of these button over here has its own number 1 2 3 to 10. So if you look over here, when you select it, over here you will have a button ID which basically tell us what sprite number we need to put on over here. And let's go over here to our code in the level button asset.m, and over here into the init with dictionary parent method, we have these these lines over here, which basically looks inside our object, our asset, and looks for the child node with name counter. Now if we unlock one of these assets and we look over here, we have the counter sprite over here, which is basically the number displayed on the button. And if we look in the sprite sheet that we have over here, this counter sprite comes from this level select sprite sheet. Looking over here, we will see that each of all these numbers are named level select 9, level select 8, level select 20, level select 1, and so on. So what we do in code over here, we are retrieving the sprite that represents our number, and if we find it, and we need to find it because it's there, it's called counter, we then look at the level ID, we read the level ID from the user property of that asset. So over here we read the level ID property information, and then we create the sprite frame name that we must use. So it's level select and the level ID, in this case 7. And then we say, okay, on the counter sprite, set sprite frame with name, and the sprite frame it will be level select 1, level select 2, level select 5, and so on. So that's how you basically can create sprite sheet animation or change the texture information on a sprite. Now let's look at this level ID member function over here. And this is actually a helper function to help us retrieve the property information for the level ID info. Now we have the class button info, which is retrieved by self user property, and user property over here, it's let's find it. It's an object. It can be any type of class which conforms to the LevelHelper user protocol. So in our case, it will retrieve us button info, because over here on each of our assets we have the button info set as the user property. So we retrieve this, we check if it's actually a button info. Maybe we did some error in our levels, and we actually didn't assign a button info class to our node. And then from the button property, from the button info object that we have over here, we can retrieve the information we require. So our level ID float number. So we get the float level ID, we cast it to an int because we need an int, and we return this int value. So we can create the sprite frame name and then assign the sprite frame name to our counter sprite. So that's how we change the representation number on each of these button. Now what we want to do next is actually unlock or keep it lock the button over here, because when we play a level, we want to unlock the next level if the user has played a level. And in the case of the very first level, we want it to be unlocked, because if I click over here, as you can see, it doesn't start our level file. So what we do here is check if our button is unlocked, and let's go a little bit to our is unlocked method. This is again a helper method, and if it's the very first level, so if it's level 1, we always return true because we always want the first level to be unlocked. And then we look in the user defaults and search for the top level reach. This is a property that we set whenever we whenever we finish a level. And if we look into the game logic over here, when we finish a level, we will save the user information, and we will say okay, stars captured for the level ID, and we will create this key value, which will be the current level ID, which I will show you how to capture. And we save the total stars captured, and total stars captured, it's actually just an integer variable. So if we look over here, this is an integer variable in our game logic that just gets added +1 whenever we collect a star, and then we save this information so that we can show it in the level screen. And for the top level reached, we first look, okay, do we have this property into the user defaults? And if this property that we already have into the user defaults, it's smaller than the current level ID, then we say top level reach is the current level ID +1, so that the next level gets unlocked. It's that simple. So let's go back to our level button asset over here, and let's actually play the first level over here. So I'm gonna play this, and I'm gonna cut this, and as you can see, I've captured 3 stars. And now I'm gonna go back to my level select screen, and as you can see, this information has been updated to say, okay, 3 stars have been captured and the next level is unlocked. So back to our level button asset, whenever these assets are getting loaded, if the level is unlocked, then we search for the child node which represent the lock, and set the alpha to 0. We basically hide away the lock sprite. And if you look into our asset that is expanded over here, we have the lock button over here, and it's called lock. So we search for this sprite and set alpha to 0 to hide it. Now we have then look, okay, how many numbers of stars we have collected for this level. So let's look into our helper function over here, and what this does is, if the level is unlocked, so if we never played that level, we return 0, because obviously if the level is locked, we haven't played it, so we didn't collect any stars. And the next thing is generating a key for our level, which is the level ID, which we have this method over here, we already use it, and say star capture for level ID, and ampersand d to generate our key, and then we look in the user defaults and retrieve the integer for this key. Now, if this key doesn't exist, user defaults will return us 0, which is exactly what we need, because it means we haven't collected any stars for this second level or any of the level over here. So then what we do over here is, okay, if unlocked star is bigger than 0, then we search for star A, which over here, as you can see, we have fill star A, fill star B, fill star C, which are stars that are on top of the empty stars and have opacity 0. So if, for example, if I do this, you see, I can see the fill star. So what we do over here is search for first star and set the alpha to 255 to make it visible. Then if unlocked star is bigger than 1, we search for fill star B and set alpha to 255. And finally, if we have more than 2 stars that were collected, then we search for fill star C and set the alpha to 255. So over here, if we play second level, let's collect only 2 stars. Let's cut this. And now let's cut this, and now let's leave the ball rolling. And now we only collected 2 stars, and as you can see over here, it shows us that we only have 2 stars collected, and it has automatically unlocked the next level. That we know what's inside the implementation of the level button asset objects. Let's go to the level select scene over here. So when we are in the main scene, when we click on the play button, we load this level select scene. That's how it was changed to actually load this screen over here. So let's go back. When you click on the play button, we load this scene. Now you may see that this has been reset. That's because in the main scene over here, I have this setting over here to always reset what the progress, so that you can actually test and see if the game is running correctly. If we are to comment this, whatever we play once, then it will be saved for the next session. So in the main scene, if we click on the play button, then we will go to this level select scene. So let's look in the level select scene implementation, and this actually loads the level select screen level file. So it loads this level file, and then it has this method to know what's our buttons custom subclass, in our case level button asset. And then it has the helper method to go to level, and it loads a game guide scene with the level file and the level file name. Now this is called whenever we click on a button that it's unlocked. So over here we have subclass touch ended with events, and we iterate through all the touches, and we find the location in our game world node, and then we say, okay, call this method, call this helper method handle nodes at location. Or when we have the macOS target, we just use mouse up, we subclass mouse up, and the same from the event location in node, and the node is our game world node, because everything is added into our game world node. Uh, and then we call handle nodes at the location. Now this handle nodes at the location will use the node at point, which is the location we have just clicked, and it will retrieve get us an array with all the nodes that are at that location. Then we for loop through all the nodes, and if we find one that is of class level button asset, which is all of our buttons over here, then we say, okay, if the node is unlocked, you remember that this level button asset has the is unlocked method over here, which has this helper method that tells us, okay, we have reached that level, we can actually play the level. Now, if the level is unlocked, we go to this level by calling our helper method go to level and the level name. And the level name is actually the level file that we return from the user property. So over here, each of our button has a user property called level file, which will tell us the name of the file that we must play. So if we look in our scenes over here, we can see that we have a lot of level files, and each of these have the exact same name as the one over here. Bamboo Forest level 05, Bamboo Forest level 06, and so on. So that's how we know how to load this level that it must get loaded in order for the user to play. Now, in the case where the node is not a level button asset, but it's actually another node, we check for its name, and if it's called go to main menu, as over here, this flower button over here, it's called go to main menu, we just actually present the main scene again. So if I click over here, I'm going back to the main scene. So that's how we change the levels in the level select scene. That's how simple it is. So over here we have present scene, the game guide, scene with level file. This is another static method which actually is like this. So we create the file that we must load by using a string with format. We say that okay, this level file must be in published resources. Then we get the level file name we just passed from our function over here, from our level name from the button, and we add the extension, and that's how we actually initialize the level. So that's how simple it is to load the level we required. Let's talk a little bit about saving user progress and collision in the levels. So if we look in the game logic, so we actually, when we load the level, we actually load the game guide, but game guide is actually a subclass of game logic. So we must look in game logic to see the actual implementation, because the part of the game guide is just there to show our in the first level to show this hand playing. So let's look in the game logic for a moment, and what we have here, we have this helper method to save the user information, so to save the progress of where the user has reached, how many levels it has played, and on each level how many stars it has captured. So we look in the collision handling over here, and it's a little bit different than how it previously was in the last parts. That is because I have added elements like ground elements and other interactive elements with which the candy can collide. So we have changed a little bit of the handle collision with node. It's not a big difference. We can you can compare with the previous version, but it's really simple to look at. Basically, we check what's the other node that the candy has collided, and if it contains the tag star, then we remove the star and we say this variable we have over here, we say that we increase this integer variable to say, okay, I capture 1 star, 2 star, 3 stars, and so on. And if we collide with our node that it's called win, then we have won the level, and we before changing the scene in with a delay of 2 seconds, we save the user information. And if we have collided with the physics bottom boundary, then we remove the candy and we go back to the level select scene again. But in this case, we don't save any user info because the user has failed to actually finish the level. So let's look a little bit over here. We already discussed this method, but we haven't discussed current level ID. Now over here, as you can see, each of the level we load has a user property of type level info, and from this we get the level ID of the current level that it's played. And if we load one of these levels, so all of the levels from 1 to 10, if we load one of it, over here you will see that I have changed a little bit. I have organized the levels, so we have put everything that should be in the back. It's in the all background nodes. All the game elements is in a node called all game and elements, and I put it over here, and you can just then move it up and down if you need. The same with the background node. You can move it up and down. The entire level file, you can move it up and down because it's added into this helper node. And all the front elements are like the front grass, are added into this all front node, so that we can move it up and down if it's required. Now if we click on the game world over here, this is a great way to set user information in a level that you must do certain action based on. And we have this user info property called level info, which only have the member level ID, which in this case it's 8 because the level number is 08. And if we look in the properties manager over here, the level info over here has this number member variable that we must use into our level. So back to our code over here, we have this helper method to get the level information, level info class from user property, and then we check if it's really a level info class, because here we cast an ID object to a level info, so it may be something else. Maybe the guy that has created the level has done a mistake and assigned a different class property over there. And if it's okay, then we retrieve the level ID property from the class, and we return it. And then we over here in the save user info, we generate the key for captured stars, and we generate the key for top level reach. We save this information, and we only save this information if the current level ID it's smaller, it's bigger or equal with the top level that has been reached. So if the user, for example, let's play this level. So if the user, for example, has played through level 9, but now he's playing level 4, we won't set as the top level reach, we won't set level 4 because the top level reach is already level 9, so we don't want to practically reset the user progress in the game. So yeah, that's all the changes done in the collision department and how you save user information. Let's go ahead and see how we can add ambient sound to our game. So if we look in the app delegate and app delegate Mac, which if you see over here, the app delegate Mac is only for the Mac OS target, and the app delegate it's only for the Box2D iOS target and the SpriteKit iOS target. We have these lines over here that basically finds in our bundle the jungle theme with extension cough, which we added as a resource file over here, jungle theme. And let's go back. And then we load an Avo player object using this file URL that we have taken from our bundle. We say to loop always by infinity, and then we start playing the file. For Mac, during the course of recording this tutorial, I disable the sound so that I can talk freely. Now, another important thing is you need to import this Avo Foundation header from the Avo Foundation framework, but in order to do so, you need to go to the Give Me Candy Xcode project over here, and on each target over here, you must go and add the Avo Foundation framework in order for this to work. So now if I am to play the macOS target, let's close it and compile and run again, it will play the jungle theme, as you can hear in the background, and it will play that infinity. The last thing we will talk about in this part of the tutorial is how we added support for iPhone 6 and iPhone 6 Plus. So first you will need Xcode 6, and then if you start from this project, you won't have to do anything. If you create a new project using the LevelHelper template right now, it will already have support for iPhone 6 and iPhone 6 Plus. If you have started this tutorial long before iPhone 6 and iPhone 6 Plus was released, then in this case you'll have to do these changes. First, open your project and go to the project settings and add two devices by clicking over here. You will add a device called iPhone 6. You will get the white 1334 by 750, and you will set the suffix to -667 with ratio 1. Then you will add another device, iPhone 6 Plus, with 2208 by 1242 with -736 around the 2x with ratio 2. And that will be all in LevelHelper. Now, LevelHelper will tell you that some of the sprite sheets were generated with different project structures, so it will open them. All you need to do is save the sprite sheet, and that will be all. All the levels will be updated accordingly. Now, for the backgrounds, you will have to provide two new files with the required screen resolutions. So 667 with which will have this screen resolution 3034 by 750, and 736 around 2x which has the 2208 by 1242 pixels, and just provide these images in the background, already included in this part of the tutorial, so you can take them from there. Now in Xcode will by default will run with you can actually build and run for iPhone 6, but the resolution on the device will be the one for iPhone 5, because Apple wanted to keep background compatibility with old devices when moving to iOS 8. So what you must do in order to run at native iPhone 6 and iPhone 6 Plus resolution, you must go to the Give Me Candy Xcode project over here, and for each target you only care for the iOS targets, so the Box2D iOS target and non-Box2D iOS target. You must select them and then go over here to app icons and launch images. In my case, I already have a launch image. You will have a button, use launch image or something like that. So click on that button, it will create these launch images. It will create this images xc asset file. Over here, you select the image x asset and then you click on the launch image and you say, okay, you want to support iOS 8 portrait landscape and iOS 7 portrait and landscape for iPad and so on. And then you need to provide all these images. Now, if you go and show in Finder, you will find exactly the right image in this project. So basically you need the default 568, which is the one for iPhone 5 and 5S. You need 667, which is the one for iPhone 6. You need this one, which is the one for iPhone 6 Plus. You also need a landscape one for iPhone 6 Plus, and then you also need the one for old devices and the one for iPhone 4 and 4S, which is the one with 3 inches. So that's it. Then it will run on the native resolution of the iPhone 6.